So today we are going to do the inverse trig integrals. There are only 3 you have to know for the AP exam, and here's what's going to happen. I'm going to write them up. You're all going to panic, and then I'm going to explain how it works, and then you're going to be just fine. This is actually one of the topics that goes better, believe it or not, but I have to write the information up there, okay? So try as hard as you can to not freak out while I write these. You're just going to copy them down. We're all going to take a deep breath, and then I'm going to explain what it all means, like I always do, okay? All right, so there's 3 of them that you have to know. That is the first one. And these patterns typically have the du in the numerator, but I don't like that. And this was the first year. Many of you also said you didn't like that. So I put it off to the side for both of us. Oh, whoops. And then here is the third one. So those are the 3 that you need to know. I'm just going to wait while everyone copies them down, and then you're just going to hold on while I talk to you for a second. Okay, so the first thing is knowing when you even need to use one of these patterns. The common mistake is people mix these up with a regular old U substitution. So here's how you tell the difference. Do you see how all 3 of these simply have a 1 in the numerator?
Yes.
If there is anything else, like a variable or like an X there, it's not one of these. Cool?
Yeah.
That's how you can tell. Because the common mistake is people will start putting arctangent and arcsine in there, and it's not. It's just a regular old U substitution like on your quiz review, and you don't even need the pattern. So just make sure there's nothing else in the numerator. All right, second thing. You don't really need to memorize the left side of the equal sign. All you need to be able to do is write the answer. So it's really just identification. Is it sine, is it tangent, or is it secant? Okay, so first of all, in my opinion, the most obvious one is tangent, arctangent. What is different about tangent versus the other 2? Perfect. The one that doesn't have a square root is arctangent. You all good with that?
Yep.
Okay. Then between these 2 that have the square root, what does this one have that this one doesn't? It has that little doodad out front. So if there's no square root, it's arctangent. If it has the little extra doohickey thing, then it's arcsecant, and the other one's arcsine. Really, that's it, okay? And then when you look over here, do you see how it's arcsine U over A plus C? This is arctangent U over A plus C, arcsecant U over A plus C. Do you see how they're all U over A plus C?
Yeah.
They're all the same, all right? The only difference is arcsine doesn't have that fraction out front, and arcsecant does have an absolute value. I think Delta Math will accept it even if you don't put the absolute value, but I'm not 100% sure on that. So just try to remember to put it. Okay, that was my pep talk. Let's do a couple of problems. All right, so here's the first one. Well, wait until we actually do a problem.
I mean, like this.
So what you want to, oh, you said it already. It's arc what? Arcsine. And if it's a multiple choice question, you could maybe pick the answer just based on that. But how do you know it's not just a regular old U substitution where you would write U equals the stuff? There's just a 1. Okay, there's not another variable there. So now we're going to write off to the side what's A and what's U. A is a value. It'll be a number. U is a variable, okay? In this case, A is 8. Where did I get that from? Perfect, all right. U is 3x. Where did I get that from? Square root of 9x squared. All right, now I'm going to cover all this up, and we're going to do the exact same thing you did on your quiz review. U is 3x, so what's du? 3 dx, and then you would adjust with a 1/3. That is no different than what we've done before, correct? You all just did that beautifully on your quiz reviews, so do it again. That's all that is. All right, now when we go to substitute, 1/3 goes out front, du goes at the end, and what's still there is 1 over square root a squared minus u squared. After we do a couple of them, I am okay with you skipping that step and jumping straight to the answer, because as long as you realize it's arc sine, you can just write the answer. So this answer will be 1/3 arc sine u over a plus c. Well, what was u? Yeah, look back at your little list. 3x over 8 plus c, and that's the answer. So it's really just identification of which one it is. Once you do this, you can kind of just write the answer. We're going to just try a couple more, okay? So do you see how there's a 5 in the numerator? That's fine. You could even evict the 5 out and put it out front. In fact, you know what? Let's do that. You want to do that? Take the 5 and put it out front. Now it's a 1. There, you just moved it. But there's not an x in the numerator is the point. Already, can you tell which one of the 3 it's going to be? Arcsecant, because you see it has the square root and it has that extra little doodad out front. So like if it's multiple choice and there's only one choice that has an arcsecant in it, you can just circle the answer and move on, right? Okay, I'm still going to show you how to work it out. A is going to be a number. U is going to take the place of the variable. So what do you think A is going to be? 3, very good. And U, 4x. Just 3. The negative is part of the pattern. If you look up here, do you see how it's subtracting? So the negative is just part of the pattern. That's a really good question. All right, I'm going to cover up all of this. If u is 4x, what is du? 4 dx. And then we're going to adjust with a 1/4. So when you go to substitute, that 1/4 would go out front. Oh no, there's already a 5 there. That means it's really 5/4. And then this will be 1 over u square root of u squared minus a squared du. But again, if you get to the point where you want to skip writing that, like if you just know it's going to be arcsecant, then I'm fine with that. That's totally cool. In fact, the next one I will skip that. I'll show you what I mean by that, because you don't have to really write all that out. So now you have to know how to write the answer though. 5/4, and then arctangent and arcsecant do have that 1 over a out front. So for us, that would be 1 over what? Over 3. Arcsecant, u over a plus c. So that would be 4x over 3 plus c. And this one does have the absolute value. So just try to remember to put it. Now, simplifying this down, I'm going to just erase so I don't have to write the whole thing over again. Your 5/4 times your 1/3, that's going to combine to be what? Yeah, 5/12 out front. No, it's really not. It's mostly identifying like when to use it. Because I get people that will try and use one of these patterns when it's not. It's just like a regular old U substitution. I'm going to throw some boundaries on this one for you. That's what I was scared. We're gonna do some unit circle
Oh, okay.
in reverse, because it's arc, whatever. Inverse trig. I love me some unit circle. We're practically to that unit in pre-calc.
Ooh. I was.
They're gonna be
We
fun.
should spend a whole unit learning about the circle.
All right, which one is it? Just identifying. Arctangent. All right, so we're gonna find A and U. What is A gonna be? 2? U, I made this one simple because I gave you boundaries. It's just X. And so du is just dx. There won't be an adjustment. I was trying to make this one more simple because we are gonna have to do the boundaries. So I will skip writing that middle step. It's gonna be 1 over A, so that's 1/2 arctangent. Hold on a second. U over A, which would be what? X over 2. We're not gonna put a plus C because we're gonna do such that 0 to 2. Now you're probably like, hey, she didn't change the boundaries. I wouldn't on these because it's just very pattern driven. See how we still have an X in there? There's still X numbers, so I would not change them. I was thinking that was gonna answer your question. That's why I asked you to hold on, but okay, what is your question?
The question was,
So that's part of the pattern. See how it's still A squared and U squared. So you do still do the square root of another good question. All right, so we're gonna do upper boundary minus lower boundary. So if you plug in 2 over 2 is 1, and I am gonna write this out. It's 1/2 arctangent of 1. And if you plug in 0, 0 divided by anything is 0. So we got a 1 there and a 0 there. So arctangent of 1, I'm going to talk you through this. Tangent is opposite over adjacent. So if you think of having a triangle, how do you end up with a 1? You have something over something, but it equals,
yeah.
good. It's going to be your root 2 over 2, root 2 over 2, because anything over itself is what? Did you come with me on that? Okay. What is the angle? And it's going to be pi over something for your root 2 over 2. Pi over 4. So this is 1/2 times pi over 4. They do arctangent of 1 a lot for that reason. So it's the pi over 4. All right, minus arctangent of 0 is 0. If you think about on your unit circle here, I'll illustrate it for you. Do you see how that's the point 1, 0? 0 over 1 is 0. I tend to just remember tangent of 0 is 0, so arctangent of 0 is 0. So anyway, but I digress. This is gone because it's nothing. And how would you simplify that first part? Be pi over 8 as your final answer. I'm going to have you guys try one. I'm going to write it up here and then I'll hit pause and have you try one with your group, okay? I will not put boundaries on it. All right, give me a perfect square. Or 49. Do minus 81 x squared dx.
I see what you're.
All right, so what did we let A and U equal? 7 and 9x. Okay, so at that point, I'm going to cover this up. That means du is 9 dx. I'm going to adjust it with a 1/9. Okay. Arc sine, arctangent, or arcsecant. Arc sine. It's got a square root, but it doesn't have the extra little doodad out front. So it is going to be 1/9. Oops, why did I write a 2? That was like a brain hand disconnect there. All right, 1/9 arc sine. Oh, why is there not another fraction out front? Yeah, for arc sine, that pattern doesn't have another fraction. We only have the 1/9 from our adjustment here. 1/9 arc sine of what? Yeah, it's u over a, so 9x over 7 plus c. How'd that go?
I mixed up the.
Okay, so this one didn't have like a little thing out front. We're gonna do one more.
I read, I only just mixed it up.
Just write the answer. I like that. I'm gonna write down the equation so I don't like this anymore. Yeah,
I can do this.
Oh, I don't like this anymore.
I can do this.
You will in a second.
Because
Hold
I know
on.
what it-
So the reason I threw this on here as a last question is the common mistake is people go, oh, x squared plus 1 and 1's a perfect square and this is perfect, like x squared. And people go, oh, it's arctangent. And on the multiple choice, they will put a choice that says arctangent to try and throw you off. Why is it not? Variable. It is a regular old U substitution like on your quiz review. What would you let U equal? And humor me if you're like, we know how to do this. Do it anyway, because again, people mix them up. That's why I'm saying it. Du good would be 2x dx. Adjust it with a 1/2. So you can fly through that once you get good at it. 1/2 goes out front. Du goes at the end. What's still there? 1 over u. And what's your antiderivative? 1/2 ln absolute value of the stuff, the u, x squared plus 1 plus c.